I want you to find C. You can't answer this question. All right. How'd you find C? Long, what'd you try?
What?
What'd you try?
What do you mean?
What'd you try?
Did you actually try it?
Tell me what you tried.
The over thingy.
The over the thingy?
The C over sine.
Okay, so you did C over sine C,
Yeah.
right? So you do this, you did C over sine of 37 equals what?
8.
8 over sine 11. 11 is a what? A side. So can I sine 11?
Yeah.
No, we can sine A, but we can't sine 11. Okay? We can sine A, but we can't sine 11, right?
Right.
Okay, so will that work? No.
Is that 8 over sine? I don't know.
Yeah. So we can sine A, but we can't sine 11. Right? So that one doesn't work, so I have two unknowns, right? Right here. So C over sine 37 equals 8 over sine A. Can't do it that way. Right? What else? Anyone else try anything? Anybody try SOHCAHTOA?
No. You can do the A.
I was about to.
A squared.
A squared plus B squared equals C squared?
Yeah.
So I can do that?
No.
Why not?
That's right, little kid.
Ah, it's not a right triangle. What it looks like, yeah, but looks can be deceiving. Right? What else? SOHCAHTOA. Will SOHCAHTOA work?
No.
No, because it's not a
Right.
right triangle. So, law of sines, what doesn't work? Too many unknowns. A squared plus B squared doesn't work near SOHCAHTOA because it's not a right triangle, so we have to learn something
No.
new.
Again?
Yep. So,
You just.
this is the last one. Remember? I said we're going to do one more. This is it. Okay? So, this is the last law of this unit. Alright? This is it. Alright? Now, this triangle, make a little note. Guys, make a little note under your warm-up. We cannot find C because law of sines doesn't work. There's too many unknowns. Right? Remember, law of sines only work if you have an angle and the side opposite, right? Or the side opposite and the angle. You need all the A's or all the B's or all the C's. Right? We don't have that, so law of sines don't work. It's not a right triangle, so SOHCAHTOA or Pythagorean theorem don't work. Right? So we need something different. Can you see how I might use a triangle like this to try to bait you into using SOHCAHTOA when you can't?
No.
Because it looks like a right triangle? Or try to get you to use Pythagorean theorem when you can't? Because it looks like a right triangle? Yeah? So be careful when you're doing your work. Make sure you know it's a right triangle before you apply those ideas. Alright, so we were here. Now we're here. What we need is something called the law of cosines. Okay? The law of cosines is, and this is already written down in your paper, the law of cosines is a generalization of the Pythagorean theorem relating the lengths of the sides of any triangle. Okay? If you look at the equation for law of cosines, it looks like the Pythagorean theorem, doesn't it?
Yeah.
Doesn't it? When I look at this last one, A squared plus B squared equals C squared, right? But then they added a bunch of stuff here on the end. Okay? Why do you think they had that bunch of stuff added on at the end?
So it's not a right triangle.
Because it's not a right triangle. Because math is confusing. No, it's not a right triangle.
No, it's not.
Now, does anybody know what cosine of 90 is on your calculator? Can you try cosine 90?
1.
Not 1. What is it? 0. Thank you, Whitney. Cosine of 90 is 0. So if this were a right triangle, C is the hypotenuse, 90 is the one opposite it. If I do cosine 90, we get 0, and this all goes away, and we have our Pythagorean theorem. Okay? So this does work for right triangles as well. Just like law of sines will work for right triangles, so will law of cosines. All right, so on your paper, you have a part where it says law of cosines for sides, and you have a part where it says law of cosines for angles. Do you guys think that these three equations are for finding sides or finding angles? Sides. Why?
Little. Lowercase.
Okay, because the little one is solved for, right? Okay, so these are all for finding sides. Now, you may notice a pattern here. If I have A here, do I ever see little a again? No, but what A do I see?
Big A.
Big A. Okay, so one way to remember this is if it's the thing I'm solving for, if it's A, B, or C, if it's what I'm solving for, then that's what I'm taking the cosine of. And I use the other two sides to make up the equation. So that's kind of the pattern you see. A squared equals b squared plus c squared minus 2ab cosine a. The next one, we're solving for b, right? So all of our b's became a's. And we're taking the cosine of b. Okay. The next one, all of our b's became c's. They switched. Right? So, Long, you have to memorize this?
Yeah.
On the test, I think, not going to be for sure, I think you're given just one. That's this one. C squared equals a squared plus b squared minus 2ab cosine bc.
Yeah, that's good.
Okay? So you need to know how to go back and forth between them. Okay? You won't get all three. You just get one. Okay? Does that make sense?
Why didn't you give it?
Okay, write it down. Because I want, because there's some,
Write that down.
Wait, so we
write it down where it says law of cosines for finding sides. Yep. So where it says law of cosines for finding sides, write that down. Now you guys have a triangle that looks kind of like this one on your paper, right? Remember, little letters are sides, big letters are angles, and angle A is always opposite side A, angle B is opposite side B, angle C is opposite side C.
This is for finding sides?
It's for finding sides. You know how I know it's for finding sides? Because it's solved for a little letter, just a little letter by itself. Little A or little B or little C. You should be writing down the 3 equations for finding sides. You can write just one of them. Those are your notes. What? Right, that's for Pythagorean geometry. This is Pythagorean geometry. They're always added to be subtracted to AB cosine. Or to BC cosine.
Dude, I can't get this off. It be hurting. The thumbs be hurting.
Guys, please label the triangle to the right. Please label the triangle to the right, A's, B's, and C's. Just so that way you have the reminder and you get the practice of writing little a across from big A, little b across from big B, little c across from big C. I think I'm going to open up a sandwich shop. I'm going to open up across from every Big B coffee. It'll be called Little B sandwiches.
I don't get it.
Because Big B and Little B are always across from each other. It's like Big B will to the road, Little B sandwich to the other side.
Dear Kern.
Yeah, think it'd be a good idea?
No.
Could make them all non-right triangles. Be kind of cool. No? I know. The thing is that we've identified the problem now. We just got to figure it out how to solve it. You guys don't like my idea? Little B sandwiches?
I did.
Thank you, Maddie. Appreciate it. You have any likes too? Well, triangle sandwiches.
Great idea.
Or maybe we could just serve pizza. That's all triangular. Little B sandwiches. All right. Are you guys ready? Ready to try this out? See how it works? Okay. Oh, wrong button. So on your notes, you have a part where it says teaching example 1. This is teaching example 1. So I'm going to go through how to find C in this triangle.
Where do you see that?
Okay? Right below where you just wrote down law of sine. Oops, law of cosines. So I'm going to find C in this triangle. Give myself a little more space. All right? So the first thing we should do whenever we're given a triangle is label our sides so we don't get confused. All right? On here they labeled C and little c, big A and big B. I need to label little a and little b. Which number is little b? 11 is little b. So it's across from big B. So that means 8 is little a. Okay. Now I want to find little c. So should I use the equation that has c by itself, a by itself, or b by itself?
C by itself.
C by itself. Good. So that equation is this: c squared equals a squared plus b squared minus 2ab cosine big C. Right? So that's the equation I'm going to use. So, write it out. C squared equals 11 squared plus 8. Oh, got it backwards. It doesn't matter if you get it backwards. 8 squared plus 11 squared minus 2 times 8 times 11 times the cosine. Oh, what's big C? 37. Oh my goodness. We're not doing any algebra. All you have to do is solve. Or just type in your calculator. It's too much.
Don't you times that by cosine 37?
Yep. So 8 squared is 64. 11 squared is 121. 2 times 8 times 11 is 176. Cosine 37, I can't do that in my head. Everyone has their fault, right, Lon? 0.799.
Wait.
You with me? Okay. 176 times 0.799 is 140.55. So this is 185 minus 140.55. You did 56. Sorry. 56. Do that subtraction. And we get 44.4. So is that how long C is?
Yep.
No, that's not how long C is. It's close!
You have to do that one.
We gotta square root it. You gotta do something radical here. So we square root 44. Oh, that's wrong button.
Is that 140.56 or 55?
0.56. I rounded incorrectly the first time. And the square root of 144, or 44.44? Anybody know?
6.67.
That means C is 6.67. Does that make sense, guys?
Yep.
Okay. Now, could I have just plugged this all in one step and got my answer?
Yeah.
Yeah, you can literally do 8 squared plus 11 squared minus 2 times 8 times 11 times cosine 37. You can do it all in your calculator. Just type it in as you see it, and it will work. Okay? Assuming 1, you're in degrees, and 2, you make sure you do the right signs. All right? Don't put a multiplication here. Make sure it's addition. Make sure this is a minus sign, not a negative sign. Remember, there's a difference on our calculator, right?
Yep.
So you can do it all in one step as long as you punch everything in correctly, and it will give you the correct answer. And then you have to square root at the end, though. It'll give you 44.44, and you have to square root. So you'll still have to do this part. Okay. Try if not to. It'll take you from here to here.
Did I have to do with times in between the cosines?
No, you can just write cosine. After 11, you can just write cosine 37 if you want to.
I got 50.28.
50.28 means you didn't plug it in correctly.
Let me try.
I got that.
Wait.
You got the right answer?
44.44.
Okay, so then you got to square root it, and it works.
Dang, why is your calculator so junky?
All right, any questions? Let's get
Yeah,
a brand new
I
one.
didn't get it.
Here, let's see it.
This is new.
That's a new calculator. Yeah.
Oh, am I not in degrees?
I got it.
Yep, you're in radians.
Okay, fill these buttons.
There you go. Because you spilled your slush on it multiple times.
Name Harvard.
But they feel.
All right,
Oh.
next part at the bottom. I don't know if you guys see it, but it says, now that you've found C, I want you to find A and B.
Separate.
Okay? Now, the cool thing about law of cosines is I can really use it as much as I want to or as little as I want to. But the bad thing about law of cosines, it's a big, ugly equation. Right?
Yep.
If I'm solving for something that's not a side, there's a lot of work that goes into that. So when I want to use law of cosines to find A, no, what should we use? Nope, it's not a right triangle. Alright, someone say it over here. Law of sines, thank you, Whitney. Okay, if we were going to solve for A and B now, since we have a C and a little c, we should use law of sines. It'll make our job easier than if we try to use law of cosines again. So, my advice to you guys, use law of cosines as little as you need to. Alright? If you don't have an angle and a side combination, use law of cosines. But once you have the combination of c and little c, use law of sines. It's easier. You'll make less mistakes. Okay?
Okay.
So, let's find A by using law of sines.
Can we do
So,
that?
A is an angle, so which one do I have on top? Sine A or little a? Sine A. So sine A over little a is 8 equals sine C, which is 37, over little c, which is 6.67.
Finding C. This is for finding A and B.
Yep, that's for finding A and B. We already found little c.
So we're going back to
What was for finding angles?
We'll get to finding angles in a second.
Why
I'm
did
sorry.
you have this in
Something
order?
A.
I'm sorry. Okay. So sine of 37 is 0.602. So we have sine A over 8 equals 0.602 over 6.67. Right, what do I do now? Multiply by 8, good. Thank you, Bruno. Multiply by 8 till these 8's cancel. So we have sine of A equals 0.602. Divide 6.67 times 8 at 0.722. Is that right? Yeah? So now what do I do? Inverse sine. So A equals the inverse sine of 0.722. It is not too much. We're solving a triangle. It takes a little bit of work. What is it? 46.22. Must have a lot of ballerinas around with all these tutus. That's a pretty good one. So now we know A is 46.22. Right? How do I find B? Law of sines? Angle sum theorem. Whitney, you're on a roll today. Angle sum theorem. We know 2 of the 3 angles. We know they all add up to 180. So A plus B plus C equals 180. So we can do this. 180 minus 37 minus 46.22, and that will give us what B equals.
We're going to have to do all of that.
It's easy.
No, it's
It's
not.
long.
This is easy.
No, it's not.
We did this on Friday, and you did great at it, Along.
I mean, the first and second one, it's hard.
See, as a teacher, I love this problem because the easiest way to do it is using 3 different things. It's wonderful.
It's easy for you.
Well, it'll be easy for you once you practice.
96.7.
And how about the green?
96 point what?
78.
78. Nice job. Any questions?
Yeah, where'd you get that 180 minus 37?
Angle sum theorem.
Wow.
We know all the angles in the triangle add up to
Oh, okay, yeah.
180, right? I knew you'd get it. Okay, fine. All right, any questions? Any questions? Okay, turn the page real quick and take a look at teaching example number 2. Excuse me. Turn the page and check out teaching example number 2. Numero dos. Ladies, stop hitting each other. Okay. What's the big difference here? There's no angles. Right? We have all 3 sides. Right?
Right.
So we can't find
So, what's little a?
little A,
11.6. What's little b?
15.2.
15.2. What's little c? Little c is what? 7.4. Okay. So, if I'm going to use law of cosines now, first off, they don't tell me which angle to solve for. They just said solve the triangle. So that means I need to find everything. I need to find all 3 angles. Right? Does it matter which one I find first?
No.
No. So which one do you guys want to find first?
A.
You want to find A first?
Yes.
Okay. If I'm going to find A, the only law of cosines that has A in it is this one. That has big A in it. A squared plus B squared equals C squared minus 2BC cosine big A, right? That's the only one that has A in it, isn't it?
Well, we don't have a big A.
Okay. We don't have big A, but we have everything else. So I can plug in 11.6 squared equals 15.2 squared plus 7.4 squared minus 2 times 15.2 times 7.4 cosine A. That looks like a fun problem to solve.
No, it's not.
Can we just plug that in?
Why not?
Not in our calculator.
Oh, or cosine.
Would you rather have one you can just plug right in your calculator?
Yeah.
Would you guys rather have one you can plug in your calculator?
Yeah.
Yeah? Okay, so let's take a moment and pause this example for a second. We'll come back to it once we figure out an equation. So we're going to take this equation right here and we're going to solve for A. I want to get A by itself. Okay?
This is for finding angles.
This is for finding angles. You do not need to write this down. You just need to write down the result. Okay? But I want you guys to think through it with me because the work we're doing, I'm saving you this work every single time by memorizing this equation. Okay? So what should I do first?
And divide by A.
Divide by A squared?
Yeah.
A squared's not doing anything. He's over by himself.
So can you get it on the other side?
Why do we want it over here? We want A by itself, don't we?
Yeah.
So should we move things over there?
Sure.
Okay, so how do I move this stuff over here? Not times A.
Divide.
These are being added, right?
Subtract.
Subtract them. So if we subtract B squared and subtract C squared, they'll cancel here, right? And to subtract B squared and C squared from A squared. So we have A squared minus B squared minus C squared equals negative 2BC. Oh, not sine. Cosine big A. Right?
Do I have to move it?
Now I gotta move this, right?
Yeah.
It's being multiplied, so how do I move it?
Divide.
Divide. You know, divide was so fun. I said divide and Faith laughed. Okay, so I'm dividing by a negative, so what happens to these signs? These two become positive, and this A becomes negative, because when you divide or multiply by negative, it switches signs, doesn't it? So this A becomes negative, the B and the C become positive. Right? All over 2BC equals cosine big A. Now, how do I get rid of cosine? Inverse cosine. So I inverse cosine both sides. Those cancel. Cosine negative 1 here. And what we end up with is an equation that looks like this. Cosine negative 1 of negative A squared plus B squared plus C squared over 2BC equals big A. Long way, man.
We gotta write that down.
So now is this for finding sides or finding an angle? Finding an angle. This is used for finding an angle. So on the front page where it's set, where we have the law of cosines for finding sides and finding angles, that one right there is the first one for finding angles. How many do we need? 3. Okay. Now you do not need to memorize all 3. You can really just memorize one and recognize the pattern. You guys see the pattern here? Okay, so let's try it out. What if I have B equals cosine negative 1 of... What do you guys think? Nope. Remember I found A, right? So the first one was A. So if I'm finding B, what's my first thing?
B.
B. So it's negative B squared plus A squared plus C squared over 2 AC. And then the next one is C. Cosine negative 1 of negative C squared plus Kent,
You didn't hear her.
Faith, Andrea, 2AB. So these are your three equations for finding angles.
So we have to memorize the two of them.
Actually, one of them will be given to you, so if you can recognize the pattern.
That one and the other one.
Yep. So you'll get one like the traditional law of cosines for sides. You'll get one that's like the law of cosines for angles, but you need to know how to switch them around.
We have to.
Well, I'm just going to give you this one, so if you're trying to solve for big A, you're going to be kind of confused. So you need to know how to go from here to here. Okay? Or you can rename your triangle. And say, oh, this is A, but I only have it for C, so I'll just name this C. We'll go from there. Okay, that's allowed. Okay. Guys, this makes sense? Are there any questions?
No.
No questions? Okay, let's go back to the example then. So here's the example. Oh, too far.
What was I supposed to write down?
You're supposed to write down these. That's your
You said
law
we
of
gotta
cosines.
write down one if we get it.
If you get it, you understand the pattern. Okay. You don't understand the pattern, so. No.
Mr. Branch, you got some scissors.
Some scissors? Yeah, but I don't think it's relevant right now. I'll get them for you in a second.
Alright.
Alright, so here's our triangle, right? Here's our triangle. Which side is A? Easy.
Wait, what? 11.6?
Which side is A?
11.6?
11.6. Which side is B?
15.2.
15.2. Which side is C?
7.4.
7.4. So now we can just, they want me to solve this triangle, so I can really just pick an angle to start with. What do you guys want to start with?
A.
A? Okay, we can start with A. So we're starting with A, then we need to use this version of the cosine for angles formula. Okay. Now, when I do this formula, is this A right here? Is it A squared that's negative or A that's negative?
We want the rest of them.
Okay. In this equation, the A squared is negative. So, you know when you square something, it makes it positive automatically? Well, the negative sign is after you square it. So when you square A, you then need to make it negative for this equation to work. Okay?
Let me put this right here, right?
Yep. So now I can solve for A. A equals the cosine -1 of negative 11.6 squared plus 15.2 squared plus 7.4 squared, all divided by 2 times 15.2 times 7.4. And that equation will give me A. Now, just a helpful hint. I wouldn't just plug this all in at once. You most certainly can. But I would calculate the top and the bottom and then plug it in. So what I mean calculate the top. Just enter the top and as it looks. Negative 11.6 squared plus 15.2 squared plus 7.4 squared. Just enter it all in like that, hit enter, and you get 151.24. And then enter the bottom as you see it. 2 times 15.2 times 7.4. Hit enter. And you get 224.96. And now type that in. Just do the inverse cosine of the fraction, and it'll work. So inverse cosine of 151.24 divided by 224.96. Hit enter. And what do we get? What do we get? Good. And that's what A equals.
That's a lot of work.
Well, you don't have to find the equation every time. You just gotta plug it in. It's calculating. So now that I know that angle, how can I find the next angle? Okay, if I want to find B, we can use law of sines, right?
Yeah.
Sine of B over little b equals sine of A over little a, and it works because I have little a and big A, right? And then once we have B, we could use what then? Angle sum theorem to find C, right? But since we are practicing the law of cosines equations, I want you guys to find B and C using these equations. Using your law of cosines equations. Alright, so find B and C this way. So find B and C that way. Yeah, space.
Where?
You can just write the numbers, plug them in. Just write this. B equals this. Plug them in. Calculate them out, and then write what equals.
Where?
Underneath the triangle.
Underneath both knees? Or this one?
Put it right here. Right there. Yeah, space.
That's not how it fits.
Just write a little smaller. And get some line paper if you want it.
Thank you.
Yeah. That's a good one.
Andrea, Faith, you find these angles?
Yes, we are.
Alright.
We called it this big. She called it actually. Say it's there.
That one right?
That's what put it on.
What are you doing? Where'd that effort go?
I hate feelings like that.
Phone, you need help? That's your phone. Thanks.
You is sleep.
Your phone?
Oh my goodness.
Hey, phone.
I did stupid thing.
I don't want to put your girlfriend
Yeah. Oh.
Where? You need to put the bottom in parentheses. If you're trying to do this all in one step, guys, make sure you put the bottom in parentheses because the bottom. Never mind. The bottom has to be in parentheses.
Can it be negative or not?
Yeah, the top can be negative, it's fine. Oh, I know what.
We have to put the 11
We're
points.
doing B? Oh, you're right. Never mind.
Mr. Branch,
What?
we put 11.6 and 7.4 in parentheses.
Guys, when you're doing it all in one step, put the bottom and the top in parentheses
What
in
if
your
I-
equation. That's why. Then you do the top and the bottom in parentheses. So top and bottom has parentheses, and that'll make you more successful.
I feel like I'm not doing this right.
What?
Mr. Branch, I did this song. Does it help? So.
Show me the next one. That one. So it's negative 11. Negative 11.
So it's only what my mom was trying to kiss me at this party off right. Like 15 times.
Okay, Andrea, special.
Okay, I think I did this song.
You see? Where'd you run?
I got this first.
Can I inverse cosine then?
Oh, I forgot about that. Who, me? Okay.
Dave, you alright?
You have the parentheses.
Need help? Okay. Yes, put parentheses on top and the bottom if you're going to do it all on set.
Okay, it's on my A, B, C. Why I get an error?
Because you didn't put parentheses on the top and the bottom.
Yes, I did.
Alright, I'm taking a look at 1 second.
But they were square. But they were square.
Okay, I did it like separate. And then that was what I got.
You did negative b? Is it?
Oh, no.
Negative b?
That's why they were C squared.
So the top should be negative 41. Yep. C. Okay, so when we found big B, what do we get?
104.06.
104.06. Okay, good. When we found big C.
Wait for that one.
You haven't got big C yet? Okay. 104.06 is correct, so if you did not get that, please let me know. I'll come by and help you troubleshoot.
I'm done.
Guys, focus on your work, please. Focus on your work. Okay.
When you divided, you have to put parentheses.
Yes, put parentheses on the top and the bottom.
You cosine, right?
I did that.
What happened in the side? What? Luis, did you get 28.23?
What?
23?
That's 28.8.
20 point what?
28.8.
How? You probably rounded. Oh, I don't see how.
Alright, so what'd you get for big C?
I don't know if I got it right.
What'd you get?
I got 28.23.
28.23.
Yeah.
Okay, well, there's an easy way to see if we're right. What should all these add to?
180.
180, so check. 47.76 plus 104.06 plus 28.23. 180? You can try it on.
I got 180.05.
180.05. Is that close enough?
Yeah.
Because we rounded, right?
Yeah.
So, you think you're right, Andrea?
Yeah.
Yeah, you are correct. Okay. So, would we have to do it that way, guys?
No.
No, you could use law of sines to find B and then angle sum theorem to find C. This will just give us good practice with that version of law of cosines. Alright, last thing to talk about today. Then we have some examples I can turn you loose on.
Turn loose.
Yep, let's try your own. Alright, so when we use law of sines? When we use law of sines?
When it's not a right angle.
Okay, both of these are for non-right triangles, right? Okay, so when do we use law of sines in a non-right triangle? Not same sides. When we have the angle and the side opposite, right? So use law of sines when we have the angle and side opposite. Okay? So A and little a. Right? You need the angle and the side opposite to use law of sines. Okay? If you don't have the angle and side opposite, it doesn't work.
You just need one of them? You don't need like all three of them?
Nope, you need one combination of angle and side opposite. And then you need a third thing, like an angle or a side, depending on what the problem looks like. Okay? But you need an angle and a side opposite. Law of cosines. Well, what's this situation? What do we have?
No angles.
No angles, we have all three
Sides.
sides. So if we have all three sides, we use law of cosines. And what's the other situation where we use law of cosines?
All three angles?
Not all three angles. What was the previous example? 2 sides and 1 angle, right? And where's that angle? Look at the previous example, guys. What page over? 2 sides, top page. You have 2 sides and the angle is where? Don't say C. It is C, but where is it compared to the 2 sides?
It's in between them.
Between them. Good. So if we have 2 sides, and the angle between. Okay. So it's just like. Get my mouse over there. Where are your mouse? There you are. So it's just like this one right here. 2 sides, angle between. Okay. Does that make sense, guys? Yeah.
There you are.
Any questions?
Nope.
Any questions? Okay. No questions? All right.